At 6:15 on the morning of June 6, 1944, Greta Hinrichs crawled into position behind an MG-42 machine gun overlooking Omaha Beach. The air smelled of salt and diesel fuel from the distant ships. A light fog clung to the English Channel. Seveler was 20 years old, a former farmhand from Lower Saxony, who had been drafted into the Weimar 2 years earlier. He had trained as an artilleryman, but found himself assigned to an infantry position on the Normandy coast. His hands were steady as he checked the weapon, belt loaded, barrel locked, sights aligned on the waterline below. He had fired thousands of practice rounds during training. He had never fired at a human being. Below him, hidden in the pre-dawn darkness, the largest invasion fleet in human history was approaching the coast of Normandy. More than 5,000 ships, 11,000 aircraft, 156,000 soldiers. The Allied forces were about to attempt the most ambitious amphibious assault ever undertaken. SEO's position was designated Weiteren's Nest 62, a concrete bunker built into the bluffs above the sand. The Germans called these positions resistance nests. They were designed to create interlocking fields of fire that would turn any beach landing into a slaughter. Seville's bunker sat approximately 40 meters above sea level. He had a clear field of fire across the entire eastern section of Omaha Beach, nearly 2,000 meters of open sand. His weapon was loaded with belted 7.92 millimeters ammunition, standard German infantry cartridge, the same round the Veer had used since the turn of the century. SEO had thousands of rounds stacked in metal boxes beside his position. His assistant gunner was ready to feed belt after belt into the weapon. The landing craft appeared at dawn, gray shapes emerging from the gray sea. Sealer could hear the drone of their engines mixing with the crash of wave on the beach. He watched through binoculars as the craft approached. He could see the soldiers packed inside, standing in rows, waiting for the ramps to drop. The first ramps fell at approximately 6:30. American soldiers spilled into the surf. They were carrying 60 pounds of equipment each. They were through water that was often chest deep. They were completely exposed. There was no cover on the beach, no protection from the guns above. SEO pulled the trigger. The MG-42 erupted with its distinctive sound, a continued tearing roar that was unlike any other weapon on the battlefield. At 1,200 rounds per minute, individual shots were indistinguishable. The guns simply screamed. What happened over the next 9 hours would earn C the nickname the Beast of Omaha. But the weapon that made it possible had a story that began years earlier, in a factory that had nothing to do with warfare. The MG-42 was not designed by weapons experts. It was not built by a prestigious arms manufacturer with generations of experience. It was created by mechanical engineers who knew nothing about machine gun, working in a company whose primary product was sheet metal lanterns. The factory was located in a provincial Saxon town that most Germans had never heard of. The lead designer had never fired a weapon in combat. He had never served in the military. He was an expert in manufacturing processes, not in killing. And yet, his creation became the template for nearly every general-purpose machine gun that followed, including weapons still in service with armies around the world today, more than 80 years after it first appeared on the battlefield. Direct descendants of his design are carried by soldiers on every continent. This is the story of how a manufacturing innovation that saved roughly $100 per weapon changed the way wars are fought. This is the story of the MG-42. The problem began with the MG-34. In 1934, the German military introduced what they called the Einheitsmaschine, the universal machine gun. The concept was revolutionary. Previous military doctrine maintained separate categories for different machine gun roles. Light machine guns were portable weapons carried by infantry squads for mobile operation. Heavy machine guns were crew-served weapons mounted on tripods for sustained fire from fixed positions. Aircraft machine guns were specialized designs optimized for aerial combat. Anti-aircraft guns had their own requirements. The German planners proposed something different. They wanted a single weapon that could serve all these roles. One gun that could be carried by infantry with a bipod mounted on a tripod for sustained fire, installed in vehicles and aircraft, and used for anti-aircraft defense. One design, one training program, one logistics chain. The result was the Muskin 34, the MG-34. It was arguably the most advanced automatic weapon in the world. At the time of its introduction, the MG-34 was an air-cooled, recoil-operated weapon chambered for the standard German Schuh need to buy Fempi Schuh Mauser cartridge. It fired at approximately 850 rounds per minute, significantly faster than comparable British or American machine guns. It fed from 50 round belts that could be linked together for sustained fire, or from 75 round saddle drum magazines for mobile operations. The weapon featured a quick-change barrel system. A trained gunner could swap barrels in under 15 seconds, allowing sustained fire without overheating. The sights were adjustable for range and windage. The trigger mechanism allowed both semi-automatic and fully automatic fire. Most importantly, the MG-34 could adapt to multiple roles through different mounting systems. On its integral bipod, it served as a light machine gun. On the Lafette tripod, it became a medium machine gun capable of accurate fire at ranges exceeding 1,000 meters. Special mounts allowed it to be installed in tanks, armored vehicles, and aircraft. The German military was proud of the MG-34. They believed it gave them a significant advantage over potential enemies. In many ways, they were correct. But the MG-34 had a critical flaw that would not become apparent until Germany began preparing for a major war. The weapon was extraordinarily difficult to manufacture. The MG-34 was a machinist's weapon. Nearly every component required precision machining from solid steel billets. The receiver was milled from a single block of high-grade steel. The bolt assembly contained dozens of precisely fitted parts. The barrel extension, the feed mechanism, the trigger group, all demanded the attention of skilled craftsmen using expensive machine tools. Each MG-34 required approximately 150 man-hours to manufacture. That meant a single worker operating full-time could produce perhaps one weapon per month. In practice, production was divided among specialists at different stages, but the total labor investment remained the same. The cost was 327 Reichsmarks per unit. At contemporary exchange rates, that was roughly equivalent to 130 American. To put that in perspective, an average German factory worker earned approximately 150 Reichsmarks per month. A single MG-34 cost more than 2 months of an ordinary worker's wages. The weapon also required 49 kilograms of raw materials, primarily high-grade steel alloys containing metals that Germany had to import from other countries. As political tensions increased through the late 1930s, access to those materials became increasingly uncertain. Most critically, the MG-34 demanded skilled labor that was in short supply. Germany had excellent machinists and tool makers, but their numbers were finite. Every machinist working on MG-34s was a machinist not working on aircraft engines, tank component, artillery pieces, or any of the 1,000 other precision parts that modern military equipment required. The Wehrmacht recognized the problem. Staff planners calculated their machine gun requirements and compared them to production capacity. The numbers did not match. Germany could not manufacture enough MG-34s to equip the army they were building. In February 1937, the German Army Weapons Agency issued a request for proposals. They wanted a new universal machine gun that could match the MG-34's combat performance while being significantly easier and less expensive to produce. 3 companies received development contracts. 2 were obvious choices. Rheinmetall Borsig of Sada was one of Germany's premier weapons manufacturers. The company had been building military equipment since the 19th century. They had extensive experience with machine guns, artillery, and armored vehicles. They had the engineering talent, the production facilities, and the institutional knowledge to develop a new weapon. Stubgen of rewrote was another established arms maker. They had produced military equipment for decades and maintained strong relationships with the German military procurement system. The third company was unexpected. Mittel and Lackey Fabrik Johannes Grossfuss was located in Durban, a small town in Saxony with a population of roughly 20,000 people. The company name translated to metal and lacquerware factory, Johannes Gross Foods. Their primary business was manufacturing pressed and stamped sheet metal components. Their signature product was lanterns. They had never designed a weapon of any kind. They had no experience with military contracts. They had no reputation in the arms industry. What they did have was expertise in a manufacturing process that the weapons companies had largely ignored. They knew how to stamp metal. The man tasked with leading their machine gun project was Dr. Vera Gruner. He was 33 years old, a mechanical engineer who specialized in mass production techniques. Gruner had been born on June 7, 1904, in the village of Turpich, a tiny community that would eventually be absorbed into the town of Kulitz. Gruner's father was a schoolteacher. The family was not wealthy, but they valued education. Young Vera showed early aptitude for technical subjects. He attended the Real Gymnasium in Durban, a secondary school emphasizing mathematics and science. In 1923, he completed his secondary education in Leipzig and enrolled at the Technical University of Dresden. He studied mechanical engineering from 1923 to 1928, focusing on manufacturing processes and production efficiency. He completed his doctorate and remained at the university as a research assistant for 2 more years, deepening his expertise in mass production techniques. In 1930, he joined Gauss as a technical designer. Brunner knew nothing about weapons. He had never served in the military. He had never fired a machine gun. His expertise was in stamping sheet metal into useful shapes, using hydraulic presses and simple tooling. This apparent disadvantage would prove to be his greatest asset. The other 2 companies approached the problem like weapons designers. They tried to improve upon existing designs to refine and optimize the mechanisms that had worked in previous machine guns. They focused on ballistics, metallurgy, and combat performance. They assumed that a machine gun had to be built using traditional methods with machine parts made from solid steel. Brunner approached the problem like a manufacturing engineer. He asked a different question. Instead of asking how to make a better machine gun, he asked how to make a machine gun better suited to mass production. Beginning his design work, Brunner made an unconventional decision. He enrolled in a German military machine gun course. For several weeks, he trained alongside soldiers learning to operate the MG-34. He fired thousands of rounds. He learned how gunners carried their weapons, how they set up firing positions, how they fed ammunition belts, how they changed overheated barrels. He paid attention to things that traditional weapons designers might overlook. How did soldiers maintain their weapons in the field? What parts broke most often? What procedures took too long? What could go wrong during combat? He talked to experienced gunners about their frustrations with the MG-34. They told him about sensitivity to dirt and dust. They complained about parts that were difficult to replace. They described situations where the weapon had failed them when they needed it most. Then Brunner returned to Derbe and started designing from first principles. Traditional machine guns used precisely machine parts made from solid steel billets. A skilled machinist would start with a block of high-grade steel and carefully remove material until the desired shape emerged. The process was slow, expensive, and required craftsmen at every stage. It also wasted enormous amounts of steel. Much of the original ended up as metal shavings on the machine shop floor. Brunner proposed something radical. He would build a machine gun primarily from stamped sheet metal components. The same techniques Gauss used to make lanterns. Sheet metal stamping worked differently than machining. Instead of removing material from a solid block, stamping pressed flat sheet of metal into 3-dimensional shapes using hardened steel dies. The process was fast. A hydraulic press could form complex shapes in seconds. The parts required minimal finishing. They could be produced by relatively unskilled workers, following simple procedures. Stamped parts also used material more efficiently. There was little waste. A flat sheet went in. A finished component came out. Nearly all the metal ended up in the final product, and stamped parts were surprisingly strong. The stamping process compressed, and work hardened the metal, increasing its strength. A properly designed stamped component could be stronger than a machined equivalent made from the same grade of steel. The weapons experts were skeptical. They believed that a stamped metal machine gun would be flimsy, unreliable, and prone to failure under the stress of rapid fire. They pointed out that the forces involved in automatic weapons were enormous. Thousands of pounds of pressure repeated hundreds of times per minute. Surely stamped sheet metal could not handle such abuse. Brunner set out to prove them wrong, working with a small team that included a talented small arms designer named Horn who had previous work. At Mauser, Brunner developed a new machine gun design built almost entirely from stamped steel. Only the most critical components, the barrel, the bolt, and a few other high-stress parts would be machined from solid steel. Everything else would be stamped, pressed, riveted, and spot-welded. The design incorporated a unique operating mechanism. Instead of the rotating bolt used in the MG-34, the new weapon used a roller locking system. 2 rollers in the bolt head engaged matching recesses in the barrel extension. When the weapon fired, gas pressure pushed the bolt rearward, but the rollers prevented it from opening until the bullet had left the barrel and pressure had dropped to safe levels. Then the rollers were cammed inward, unlocking the bolt to cycle and load the next round. The roller locking mechanism was elegant, reliable, and well suited to stamped construction. It would later influence numerous other weapons designs. By October 1937, all 3 companies submitted their design proposals. Riedel, Borsig, and Stubgen both offered gas-operated designs based on conventional machining approaches. GFO submitted something completely different. The evaluation board examined all three proposals. They assessed performance specifications, manufacturing requirements, and projected costs. The decision was not closed. The Grossfaust design was selected for further development. The lantern makers had beaten the established weapons manufacturers. The initial trials of the Grossfaust prototype in April 1938 revealed areas requiring improvement. The feed mechanism needed refinement. The barrel change system was not fast enough. Some components showed excessive wear during extended firing tests. Gruner and his team returned to the factory and addressed each issue systematically. They tested, modified, retested, and modified again. They kept a design deliberately similar to the MG-34 in external appearance and handling characteristics. This was intentional. Soldiers familiar with the MG-34 could transition to the new weapon with minimal retraining. The mounts, accessories, and support equipment already developed for the MG-34 would work with the new gun. By February 1939, the improved prototype, designated the MG-39, was ready for extended testing. The results exceeded all expectations. The stamped steel construction, which critics had predicted would fail, proved more robust than the precision-machined MG-34. The new weapon was less sensitive to dirt, dust, and debris. It tolerated the kind of abuse that caused the temperamental MG-34 to jam. It kept firing in conditions that stopped other machine guns cold. Tests in sand, mud, and extreme temperatures showed superior reliability. The stamped components flexed slightly under stress rather than cracking. Looser tolerances of stamped construction actually helped rather than hurt, allowing the mechanism to function even when fouled with debris, and the production numbers spoke for themselves. The MG-34 required 150 man-hours to manufacture. The new Grossfuse design required 75, half the labor for the same firepower. The MG-34 consumed 49 kilograms of raw materials per weapon. The new design used just 27.5 kilograms, nearly half the steel, freeing up strategic materials for other uses. The MG-34 cost 327 Reichsmarks. The new weapon cost 250 Reichsmarks, a 24% cost reduction that would save millions as production scaled up. But those savings came with something else, something that would terrify Allied soldiers for the rest of the war. The new gun fired faster than any infantry weapon in existence. The MG-34's rate of fire was approximately 850 rounds per minute. That was already faster than Allied machine guns, which typically fired 450 to 600 rounds per minute. The Browning M1919 that American forces used fired at roughly 500 rounds per minute. The British Vicers were similar. The new Grossfaust design fired 1,200 rounds per minute. Some variants would reach 1,500. This was deliberate. German tactical doctrine emphasized suppressive fire, the ability to keep enemy soldiers pinned down while assault troops maneuvered. Military analysts had studied combat footage and concluded that targets were typically exposed for only brief moments as soldiers moved between cover positions. Maximum bullet density during those brief windows was essential. A weapon firing at that blistering rate put twice as many bullets on target as one firing 600. In the critical seconds when an enemy soldier was exposed, a difference could be decisive. The engineering challenges were immense. At 1,200 rounds per minute, the gun cycled 20 times per second. The bolt traveled back and forth faster than the human eye could follow. Enormous forces were generated and absorbed with each cycle. The barrel heated rapidly from the continuous friction of bullets passing through at high velocity. Gruner and his team solved each problem methodically. They designed a quick-change barrel system that allowed a trained gunner to swap barrels in under 6 seconds. A lever on the side of the receiver unlocked the barrel. The gunner wore an asbestos glove to grasp the hot barrel and pull it free. A fresh barrel slid into place and locked automatically. With practice, gunners could change barrels without interrupting their observation of the battlefield. They developed a feed mechanism that pulled ammunition belts smoothly and reliably at the extreme cycle rate. The feeding system used a ruler-driven arm inside the receiver cover that moved back and forth with each cycle, advancing the belt 1 round at a time. The mechanism was so reliable and efficient that it became the template for numerous future designs. They engineered a weapon that could sustain fire rates that would have destroyed any previous machine gun, where other weapons would overheat, jam, or simply shake themselves apart. The MG-39 kept firing. A limited production run of approximately 1,500 improved weapons designated. The MG39-41 was completed in 1941 for combat trials. German infantry units tested the weapons in actual combat conditions on the Eastern Front. The reports were enthusiastic. Soldiers loved the new gun. It was lighter than the MG34. It was more reliable. It was easier to maintain, and the rate of fire was devastating. In early 1942, the German military officially accepted the design for full production. Manufacturing contracts went to G-Faust, Maver, Gustlovka, Stadlauch, and others. The weapon entered production as the Mädchen 42. The MG42. In May 1942, the MG42 saw its first significant combat action. The German Afrika Korps deployed the new weapon during the Battle of Gazala in Libya. British troops encountered something they had never experienced before, a machine gun that sounded like nothing else on the battlefield. The human ear cannot distinguish individual shots at that cyclic rate. The brain cannot process 20 discrete sounds per second. Instead of the familiar racket of conventional machine guns, the MG42 produced a continuous tearing sound like heavy fabric being ripped apart. British soldiers said it sounded like cloth ripping. Others compared it to a buzz saw cutting through wood. The nicknames followed quickly. British troops called it the Spandau, a carryover from the First World War. German machine guns had been manufactured in the Spandau district of Berlin. American soldiers called it Hitler's buzzsaw. Soviet soldiers on the Eastern Front called it the linoleum ripper, of the way the sound reminded them of flooring being torn up. German troops had their own names. They called it the Norrensäger, the bone saw for the damage it inflicted on human bodies. They called it the Hitler saw. They called it the Sing in the Sea, the singing saw, for the distinctive pitch of its firing. By mid-1942, the MG42 was being deployed on all fronts. Production ramped up with impressive speed. German factories produced Southern 1900 FMP-10 G42s in 1942, a partial year of production. That number jumped to 116,725 in 1943. In 1944, even as Allied bombing intensified, product peaked at 200 Lus, not 106 weapons. In the final months of the war, with Germany's industrial base collapsing, factories still managed to produce 61,877 A-42s in 1945. By the war's end, more than 400,000 MG-42s had been manufactured. Despite the intention to replace the MG-34 entirely, both weapons remained in production throughout the war. The MG-34 continued to serve, particularly in roles where its ability to use drum magazine was useful, but the MG-42 became the signature German infantry weapon of the conflict. The psychological impact on Allied soldiers was severe. The sound alone was terrifying. Nothing in their training had prepared them for a weapon that screamed continuously instead of chattering in bursts. Veterans later described the visceral fear that the sound induced, a gut-level reaction that was difficult to control through discipline alone. But the reality was worse than the sound suggested. At that blistering cyclic rate, a sustained engagement lasting 30 seconds put more than 600 bullets into the beaten zone. Against exposed infantry, the results were catastrophic. The weapon reshaped German infantry tactics, while American and British doctrine emphasized the individual rifleman as the primary infantry weapon with machine guns providing support. The VH built its squads around the machine gunner. German tactics placed the MG-42 at the center of every engagement. Riflemen served primarily to carry ammunition, protect the gun crew, and finish off enemies that the machine gun had suppressed. A typical MG-42 crew consisted of 6 men. The gunner operated the weapon, controlling fire, and selecting targets. The assistant gunner helped feed ammunition belts and watched for threats the gunner might miss. He was also trained to take over immediately if the gunner was killed or wounded. One soldier carried the Lafette tripod for sustained fire position. 3 additional soldiers carried spare barrels, extra ammunition, tools, and other supplies. Every member of a German infantry squad understood that keeping the MG-42 firing was their primary mission. The ammunition consumption was enormous. At 200 rounds per minute, a sustained engagement could burn through an entire squad's ammunition supply in minutes. German logistics devoted considerable resources to keeping MG-42 positions supplied. Infantry units stockpiled ammunition at defensive position. Resupply operations prioritized machine gun rounds above almost everything else, but the weapon delivered results that justified the consumption. In defensive positions, a single MG-42 could dominate open ground for hundreds of meters in every direction. In offensive operations, the gun provided suppressive fire that pinned defenders in place while assault teams maneuvered to flanking positions. On the Eastern Front, where distances were vast and cover was often scarce, the MG-42 proved particularly devastating. Soviet infantry attacks frequently ran into walls of automatic fire that shattered assault waves before they could close with German positions. Soviet soldiers learned to fear the distinctive sound. They developed tactics specifically designed to neutralize MG-42 positions before attempting advances. At Monte Cassino in Italy, German defenders held the ancient monastery for nearly 4 months. From January to May 1944, American, British, Polish, and New Zealand troops attacked repeatedly. Each assault ran into MG-42 fire from fortified positions in the hills above. The defenders swept entire approach routes with sustained fire, cutting down wave after wave of attackers. The Allied forces eventually resorted to massive aerial bombardment that reduced the monastery to rubble. Even then, German machine gunners continued fighting from the ruins. In the Hedron country of Normandy after D-Day, MG-42 teams turned the thick bocage into killing grounds. The Norman hedgerows were ancient field boundaries, dense walls of vegetation growing on earthen banks that divided the countryside into a maze of small enclosed fields. The narrow gaps between hedgerows became natural kill zones. A single MG-42 position at the end of a lane could halt an entire company's advance. American infantry learned to listen for the distinctive sound and take cover immediately when they heard it. The situation became serious enough that the United States War Department produced a training film specifically to address the psychological impact. War Department Film Bulletin number 181, titled Automatic Weapons, American vs. German, was released in 1944. The film was designed to help soldiers cope with the fear that the MG-42 induced. The narrator acknowledged that American soldiers were intimidated by the MG-42 sound. He showed footage of the German weapon firing, then demonstrated American machine guns for comparison. He assured viewers that the German gun's bark was worse than its bite. He explained that American weapons, though slower firing, were more accurate and more controllable. The film included a dramatized sequence showing a green replacement soldier cowering under MG-42 fire. While his more experienced comrades remained calm, the message was clear. Fear of the sound was a rookie mistake. Experienced soldiers knew better. The narrator concluded with the reassurance that American weapons were superior. The German gun is good, he said, but ours is better. Historians later noted that the film was more propaganda than training material. The claims about American weapons being more accurate were questionable at best. The suggestion that the MG-42's high rate of fire made it less dangerous was simply wrong. The reality was that the MG-42's bite was devastating. Tens of thousands of Allied soldiers were killed or wounded by the weapon during the war. The training film may have helped some soldiers manage their fear, but it did not change the fundamental lethality of the German machine gun. On June 6, 1944, Heinrich Soe demonstrated exactly what the MG-42 could do in the hands of a determined gunner with a clear field of fire. Soe began firing as the first landing craft approached Omaha Beach. He fired in controlled bursts of 6 to 8 rounds, sweeping the waterline where American soldiers struggled through the surf. He watched through the weapon sights as men fell. He kept firing. His assistant gunner fed belt after belt into the weapon. When the barrel grew too hot, they changed it. Soe had several spare barrels ready. When one ammunition supply ran low, soldiers brought more from storage deeper in the bunker. The American soldiers on the beach had no effective way to respond. They were wading through water. They were carrying heavy equipment. Many had been seasick during the crossing and were weak and disoriented. Their rifles were often waterlogged and inoperable. The artillery and naval gunfire support that was supposed to suppress German positions had largely missed its targets. Soe fired for hours. He later recalled that he stopped thinking of the shapes on the beach as men. They became targets, abstract shapes to be engaged and eliminated. The MG-42 made it possible to engage so many so quickly that the human mind retreated from the horror of what was happening. By his own account, Seville fired approximately 13,500 rounds of machine gun ammunition during the battle, along with 400 rounds from his rifle when the machine gun needed barrel changes or reloading. American casualty estimates for Omaha Beach exceeded 2,000 dead and wounded on D-Day alone. German records and post-war analysis indicate that SEO's position was responsible for a significant portion of those casualties. Whether his personal claim of killing or wounding over 1,000 Americans, possibly as many as 2,000, is accurate remains debated by historians. Many scholars consider the number implausible, given the total Allied casualties across the entire 6-mile length of Omaha Beach, numbered around 2,400. What is certain is that MG-42 positions devastated the American assault waves on Omaha Beach that morning, and So's position at W-62 was among the most lethal. The American response to the MG-42's effectiveness extended beyond psychological warfare films. Military planners and weapons designers studied the German machine gun extensively. They incorporated lessons learned into post-war development programs. In the late 1940s, American ordnance engineers began work on a new general-purpose machine gun to replace the aging Browning designs that had served since the First World War. They examined captured MG-42s in detail. They stripped the weapons down to their component parts. They measured, weighed, and tested every piece. They fired thousands of rounds through captured guns to understand their characteristics. The American designers noted several features worth emulating. The feed mechanism was remarkably reliable and efficient. The quick change barrel system was superior to anything in American inventory. The stamped steel construction demonstrated that precision machining was not essential for an effective military weapon. The resulting American weapon, designated the T-161 E3 during development, combined elements from multiple sources. The operating system borrowed heavily from the German FG-42, a paratrooper rifle that used a tilting bolt mechanism. The feed mechanism drew directly from the MG-42 design. The overall philosophy of stamped steel construction came straight from Gruner's work at Gross Faust. The weapon was standardized in 1957 as the M60 machine gun. American soldiers carried it through Vietnam, where it became one of the iconic weapons of that conflict. They called it the pig because of its weight and appetite for ammunition. The M60 served through the Persian Gulf War and numerous other conflicts, though it had reliability issues that frustrated users and was eventually replaced by the Belgian-designed M240. The M60 remained in American service for decades. Variants continue in use with some units today. The M60's lineage traced directly back to the factory in Durban, where engineers who made lanterns decided to build machine guns. The Belgian FNAG, adopted by the United States as the M240, also owed design debt to the MG-42 concept. The general-purpose machine gun philosophy, a single weapon adaptable to multiple roles, came directly from the German Einheitsmaschine concept that had produced first the MG-34, and then the MG-42. The MAG's designers explicitly studied German wartime weapons and incorporated lessons learned. The French MES-52 copied the MG-42's feed system almost directly. The Swiss MG-51 was essentially a refined and improved MG-42. The Austrian MG-74 was a direct descendant. The Spanish AMI incorporated MG-42 principles into a lighter weapon, firing NATO standard ammunition. Yugoslavia produced the MG-42 as the M53, built from captured German machinery and manufacturing documentation that the Soviets had seized at the war's end. The weapons served in Yugoslav armed forces for decades and saw extensive use in the wars that followed the country's dissolution in the 1990s. But the most direct descendant of the MG-42 was German. When West Germany rearmed in the late 1950s as part of NATO, the newly formed Bundeswehr needed a general-purpose machine gun. The decision was almost automatic. Most Bundeswehr officers and senior enlisted personnel were veterans of the Wehrmacht. They had carried MG-42s through the war. They knew the weapon intimately. They trusted it. They did not want some unfamiliar foreign design. There was a significant problem. The original production documentation for the MG-42 had been captured by Soviet forces at the war's end. The factories that had built MG-42s had been destroyed by Allied bombing or dismantled for reparation. The skilled workers who had manufactured the weapons were scattered, dead or working in other industries. West Germany had to rebuild the capability from scratch. Rheinadel, reconstituted as a West German company after the war, was tasked with manufacturing new machine guns. But they had no drawings, no specifications, no tooling. They had to reverse engineer the weapon from surviving examples. An MG-42 was obtained from a museum in the United States. Engineers at Rheinadel disassembled it completely, measuring every component down to thousandths of a millimeter. They created new manufacturing drawings from these measurements. They designed new tooling based on the reverse-engineered specification. The German government paid royalties to Johannes Grasfus for the rights to produce weapons based on the company's original design. The manufacturing knowledge that Werner Gruner and his team had developed remained legally protected even decades after the war. The first post-war variant designated the MG-1 entered production in 1958. It was rechambered for the NATO standard 7.6. 2x 62x 51 mm cartridge, replacing the original German 7.9 Tox 57 mm round. The two cartridges had similar ballistics and the same base diameter, making the conversion relatively straightforward. Subsequent improvements led to the MG-101 with chrome-lined barrels and calibrated sights, the MG-102 with a heavier bolt for reduced rate of fire, and finally the MG-3 standardized in 1968. The MG-3 was almost identical to the original MG-42. The same stamped construction, the same roller locking mechanism, the same quick change barrel system, the same blistering rate of fire, though adjustable through different bolt weights. Parts between the wartime MG-42 and the modern MG-3 are largely interchangeable. A trained armorer can swap components between weapons manufactured 50 years apart. The MG-3 has been produced under license by Italy, Greece, Iran, Pakistan, Spain, Turkey, and other nations. Over 1 million units have been manufactured worldwide. The weapon has served in conflicts from the Cold War through the present day. More than 40 countries have used variants of the MG-42. MG-3 design. In the 21st century, over 80 years after Runa and his team submitted their stamp, metal prototype, weapons descended from their design remain in active military service worldwide. The German Bundeswehr used the MG-3 as its standard general-purpose machine gun until it began replacement with the Heckler and MG-5 in the 2020s. Even then, vehicle-mounted MG-3s remained in service because the newer weapons did not fit existing mounting systems. Converting all the mounts would cost more than simply continuing to use the proven MG-3. Turkish forces have deployed MG-3 variants in operations against Kurdish militants. Pakistani troops have carried the weapon along the border with Afghanistan. Iranian forces used MG-3s during the Iran-Iraq War of the 1980s. Spanish peacekeepers brought MG-3s to the Balkans. Greek soldiers maintain MG-3s in their arsenals today. The weapon that terrified Allied soldiers on D-Day continues to serve 8 decades later. Few military designs have proven so enduring. Vertiguna survived the war. He remained in Germany, eventually settling in Dresden in the Soviet occupation zone that became East Germany. His expertise in manufacturing engineering was valuable to the communist government, which were rebuilding industrial capacity. Gruner became a professor at the Technical University of Dresden, where he had studied as a young man. He rose through the academic ranks, eventually serving as rector of the university from 1950 to 196. He trained a new generation of engineers in the manufacturing techniques he had developed before and during the war. He received numerous honors from the East German government. In 1959, he was awarded the Patriotic Order of Merit. In 1961, he received the National Prize of the German Democratic Republic's Secondes. In 1969, he was awarded the Order of the Banner of Labor. He was named Honorary Senator of the Technical University of Dresden in 1979. Vergruner died in Dresden on June 29, 1995 at the age of 91. He was buried in the Waldfried Wiesehasch Cemetery in the Loschitz district of the city. His obituaries mentioned his academic career and his contributions to manufacturing technology. They noted his service as rector of a major technical university. They did not dwell on the weapon that had killed tens of thousands of Allied soldiers and established principles still used in firearms design today. Heinrich Seville also survived the war. He was captured by American forces shortly after D-Day and spent time as a prisoner of war. He was released after the German surrender and returned to civilian life working as a farmer in northern Germany. For decades, SEO did not speak publicly about his experiences at Omaha Beach. The memories haunted him. He had nightmares about the men he had killed. He wondered whether he was a war criminal, whether he had committed atrocity by firing so many rounds at soldiers who had no chance to fight back. He struggled to reconcile what he had done with his understanding of himself as a decent person. He had followed orders. He had defended his position, had done what soldiers do in war. But he had also killed hundreds, possibly thousands of young men whose only crime was wearing a different uniform. In 1963, Seville read the book, The Longest Day, by Cornelius Ryan. In it, he found the account of David Silva, a 19-year-old American infantryman with the 29th Infantry Division, who had been shot 3 times in the chest while landing on Easy Red sector of Omaha Beach. Silva had survived his wounds. After the war, he studied theology and was ordained a Catholic priest in 1954. By the early 1960s, He was serving as a military chaplain stationed in Kruhe, Germany. SEO tracked him down and arranged a meeting. The two men who had been enemies on that bloody morning finally came face to face. The two men shook hands. They talked about the war, about their experiences that day, about the years that followed. They found a measure of peace in acknowledging each other's humanity. They recognized that both had been young men caught up in forces beyond their control. SEO eventually published a memoir about his experiences titled WN62 for the designation of his bunker position. The book described his time at Omaha Beach in detail that many readers found difficult to process. He did not glorify what he had done. He simply described it. Heinrich C. died on January 14, 2006, at the age of 82. His memoir remains in print. The MG-42 changed how armies think about machine guns. Before 1942, military planners maintained rigid distinctions between light machine guns for mobile operations and heavy machine guns for fixed defensive positions. The weapons were different. The tactics were different. The logistics were separate. The MG-42 demonstrated that a single weapon could serve multiple roles effectively. The general-purpose machine gun concept became standard doctrine for every major military in the world. Today, no army separates light and heavy machine gun functions the way they did before the Second World War. The weapon also demonstrated the power of manufacturing innovation. Gruner's approach, designing for production efficiency from the start, rather than designing a weapon first and figuring out how to build it later, influenced military procurement for generations. Today, design for manufacturing is a standard principle in weapons development. Engineers consider production requirements from the earliest stages of design. Perhaps most significantly, the MG-42 showed that expertise in the specific field was less important than expertise in problem solving. A mechanical engineer who specialized in stamping metal lanterns created one of the most effective infantry weapons in history. He succeeded precisely because he approached the problem differently than conventional weapons designers. He asked different questions and found answers that the experts had missed. The factories that built MG-42s are gone. The company, Johannes Giefaus, no longer exists. The workers who stamped sheet metal into killing machines have passed from living memory. The engineers who designed the weapon, the soldiers who fired it, the enemy who faced it, nearly all are gone now, but their creation endures. Every time a soldier chambers around an MG3, every time an M240 opens fire in combat, every time military planner considers general purpose machine gun requirements, the influence of the MG-42 persists. The weapon that was designed in a lantern factory continues to shape how wars are fought. That is how innovation happens in warfare, not always through official research programs or established experts, sometimes through outsiders who ask different questions and find answers that everyone else missed. A factory that made lanterns, an engineer who knew nothing about weapons, a simple idea about stamped metal that saved $100 per gun and ended up killing thousands of soldiers and shaping military technology for nearly a century. The MG-42 proved that the best solutions do not always come from the obvious sources. Sometimes they come from people who are too ignorant to know what cannot be done. If you found this story informative, please take a moment to like this video. It helps us share more untold stories from military history. Subscribe to stay connected with these forgotten chapters of the past. Each one matters. Each one deserves to be remembered. We would love to hear from you. Leave a comment below telling us where you are watching from. Our community spans continents and generations. From veterans to history enthusiasts, you are part of something meaningful here. Thank you for watching and thank you for keeping these stories alive.